This is Mrs. Carnes. We're going to be moving on to slope today. A couple things that we need to know. Slope is what we call the rate of change. And so when we're talking about a line, because that's what we've been talking about, when we're talking about a line, we're going to have a rate of change as that increases or decreases. And we'll take a look at some different rates of change. We also need to remember and know that the variable m is always going to be used to indicate slope. So whenever you see the variable m, it usually means that that's going to refer to the slope of whatever you're talking about. Now, there's four ways that we can have lines. We can have positive lines, we can have negative sloped lines, we can have horizontal lines, and we can have vertical lines. And so we're going to take a look in this video at the positive and negative. So this we know is a positive slope. And we know that because if I was to follow this line from left to right, I would be going up that line. So it's kind of like going up a hill. It would be a positive. So we know that this is going to be a positive sloped line. So all of the slopes, all of our m's, will have to be positive values. Okay? Now let's take a look at this line. This now, if I read this line from left to right and follow it from left to right, it's like I'm going down that hill or down the line. And so we consider this line to be a negative line. And it's going to have a slope that's always going to be some negative value. Now we're going to take a look at horizontal lines and vertical lines in another video. But just know that these are the four types of lines you can have. And this video is going to focus on positive slopes and negative slopes. Now we're going to take a look at what actually slope is and what's the formula for it. So we know that m is referred to as slope. So we could always write slope is equal to m. We know that that variable will always refer to the slope of whatever we're talking about. Now the formula, one part of the formula for slope is what we call rise over run. And this would be if you were moving from point to point on your line, you would decide how much you would have to rise and then how much you would have to run. Now, rise can be considered the up or down movement on a graph, and the run is considered the right or the left movement on a graph. Now, think about the up and down. If you move up, that's always a positive number, and if you were to move down, that would be negative. Similarly, on the run, if you move to the right, that would be positive, and if you move to the left, that would be negative. Now, this part of the formula would be used if you could actually see the graph of the line. If you have the graph in front of you, then it's really easy to choose the points and do rise over run, and we'll take a look at an example like that. However, there is another part to the formula, and it's equivalent to what we've talked about. And it is the formula that says y2 minus y1 divided by x2 minus x1. And so this formula is what we use when we actually have points that have been given to us, and we want to plug it into the equation of y2 minus y1 over x2 minus x1. Now these little tiny numbers here, these are a subscript, and they're referring to the part of the point, and I'll show you what that means in a real example. So let's go ahead and take a look. So here's a graph, and it asks us to find the slope of the line from its graph. So if you're ever given a graph of a line, just like this green line we would be given on our graph, on our coordinate plane, we would have to say, okay, well, what is the slope? We know that when we can see the graph, we know that the slope is going to be equal to the rise over the run. We just got done with that part of the formula. And so what I do is I choose some points that are on my graph. So I'm going to choose this point right here, and I'm going to choose this point right here. And I have to decide from one point to the other point, how do I have to move? What is my rise and what is my run? So if I start here and I put my pencil at this point, I would rise and I would run to get to the other point. And that's how you're going to figure out your slope. So let's go back to the beginning again, put our pencil here. So if I rise, I have to decide, well, how many units am I rising to get level with that other point? And so from our beginning point to where I would have to change directions is a jump of 5. I would jump 1, 2, 3, 4, 5 units. So that means the rise that we've just had is 5. Now it's positive because we went up. Had we gone down, it would have been a negative 5. So now we're standing here. Now I have to run. I'm going to run to the right because that's how I'm going to get to my other point. And I'm going to run 1 unit, 2 units, 3 units, and now I know I'm right there. Now again, since we ran to the right, that's a positive, and so I would end up with a 3 for my run. So we would be able to say that the slope of this line is 5/3. It's a positive slope because we know we're going up that line. That's a positive line. And so we can check, yep, it was a positive slope, a positive line. That's correct. Now let's take a look at another way you can do this, because some of you are going to notice that I don't have to start at this point. I could actually start at this point and go the other way. So again, if I wanted to start here and go to this point, I would actually be moving down and to the left. And so I would end up at that point again, but this time I would be moving down 5 units and I would be moving left 3 units. So let's see what that does then to our slope. Again, if our slope is equal to the rise over the run, and I want to start at this point here, I'm going to have to move down 5 units. Since I'm going down, my rise is going to be -5. And then my run, I was moving to the left. Since we moved to the left 3 units, it is also going to be negative, so a -3. Now, what you probably can remember is that if you have a negative divided by a negative, you know that those both become positive. And so again, we just end up with a slope of 5/3. So no matter which direction you go, from one point to the other, you're going to end up with the same slope. You could have also chosen 2 other points on this graph. You did not have to choose just these points. You could have chosen 2 other points that were on this graph and done the exact same thing. So now let's take a look at another example that we would use the other part of the formula. We just looked at the rise over the run when you saw the graph. Now let's take a look at a different example. On this example, they're asking us to find the slope of a line from 2 points. Notice that we don't really have a graph here. We could put these numbers on a graph or these points on a graph and then figure out what the rise and the run is. But there's another way to do it that you might find easier once you get familiar with it. First thing that we would do is we would label the points that we have as X and Y and X and Y. Now we know that that's how you label points. X always comes first, Y always comes second. But the problem is then we have 2 X's and 2 Y's, and we have to be able to distinguish them from each other. That's where those little subscripts come in. This is X1, Y1 because it's point 1. This is X2, Y2 because it's point 2. And so now we have those X1, Y1, X2, Y2, and we know which number goes with those. So now let's go ahead and write that formula down that we were looking at that said slope was equal to Y2 minus Y1 over X2 minus X1. And all we do now is we plug in our values that we came up with. So we know that Y2 is 5. We know Y1 is 8, and we're supposed to subtract them like the formula tells us. We divide that by X2, which is 3, minus X1, which is -1. Now notice that I put the subtraction because that's what the formula tells me, and my X1 was a -1. So let's take a look and see what we do here. If we look at just the numerator, 5 minus 8 gives me a value of -3. Divided by 3 minus a -1, we know this becomes positive, and 3 plus 1 is 4. And so we have a slope between those 2 points of -3/4. And we can also see that this would be our rise, and this would be our run. And so that would be going down 3 units, and this would be going to the right 4 units, and that's how you would end up getting from point to point. So now you can see how to find the slope from a graph or from 2 points that you have been given.